Hi, welcome to another MZB125 MATLAB video. So as promised, this is again week 8 derivatives, but I'm going to deal with the idea of for loops separately in this video alone. So for loops come into part 5 of this week's exercises, where you asked to demonstrate how a for loop works by creating this function which approximates the derivative of a function using finite differences. So of course in 1 through 4 you've already looked at creating finite difference approximations of derivatives. What we're doing here is using a for loop to go about doing that as well. So you might think, why would I bother going to using a for loop? We've already done this a different way. Well, for loops are actually really useful for a lot of purposes. They're a pretty simple control thing that you can do in MATLAB. And essentially, so what it says here is it's the kind of thing you use when you want to repeat the same task over and over again. So that's what we're getting at here with a for loop. And a derivative, or a numerical approximation of a derivative, is a good example of one thing where you can use a for loop. So it's an example to basically teach you about for loops. So let's just jump over to MATLAB for a moment. Forget about the numerical approximation stuff. Let's just look at a simple for loop. What I'm going to do is I'm going to say to MATLAB for index, I'm going to call it index, for index equals 1 to 5. Now notice that it doesn't actually do anything there, unlike normally when you press enter. That's because it recognizes for as a statement which needs more input to it. So it's waiting for me to give it more. So for index equals 1 to 5, I'm going to say, well, just tell me what index is. It still wants more. What I do to finish it off is I type end. Okay, and when I hit enter in a moment, it's going to spit out a bunch of stuff. It's going to run this for loop. Okay, so there we go. What is that? Well, it's saying, here's my statement. For index from 1 to 5, 1, 2, 3, 4, 5, tell me what index is each time. And once you get to the end, in other words, once you get to index equals 5, finish. So it goes through and it says when index is 1, well, index is equal to 1. And then it goes back and again, and it says let index be 2. Well, index is equal to 2. And you can kind of see what's happening here. Each time I change the index, it spits it out and then goes back and starts again. So let's just bump that up a notch. For index equals 1 to 5, let's say what is index squared? Similar sort of thing, right? So there we go. When index is equal to 1, index squared is indeed 1. Then it jumps back up. Index is equal to 2. 2 squared is 4. Jumps back up when index is equal to 3. 3 squared is 9, and so on. 4 squared is 4. 5 squared is 20. Sorry, 4 squared is 16. 5 squared is 25. And once we've got to 5, I've told it to stop, so it doesn't give me any more things. It just spits out the MATLAB command prompt. So what I'm doing essentially is telling it to over and over again evaluate something squared, where that something is 1 and then 2 and then 3 and then 4 and then 5 and so on. Okay, so it can do this kind of repetitive evaluations. The example that you're given over here in the MATLAB exercises, there's a couple that build up to it, but the one I want to look at is this one here. It's pretty much what I've just been doing. For index equals 1 to 10, they've got different limits to me, so it's going to do it from 1, then 2, then 3, then 4, all the way up to 10. It's doing the index squared thing. Got the semicolon so it doesn't spit out the result, but each time it's also storing that result as something. So remember over here, I've just got answer equals. It's not actually storing that anywhere secure. So what we're doing here is actually storing it in a vector called square with a capital S, and it's telling MATLAB to put each value that we want to store at location index. So when index is 1, square element 1 is 1 squared. When index is 2, square element 2 is going to be 2 squared or 4, and so on down the line. So I could, if I wanted to, copy that little bit of text and take it over to my MATLAB window, plug it in, and you'll notice nothing spits out because of the semicolon, but up here in my workspace we see a square has arrived as a new object, and if we double click on that just to see what it is, it's a 1 by 10 vector, and you can see the entries are the square numbers just as we expected. Fantastic. So essentially that's how the for loop works. You give it some sort of instruction that you want to be carried out over and over again, and if you include a reference to the indexing variable, it's going to do that for different values of that indexing variable, where the values it uses are the ones you specify here in the for statement. Okay, so jumping back to our MATLAB exercise, okay, we're going to try to create a function. Now the thing is here that we've actually given you all the content of the for loop. The instruction is just to calculate the approximation of the derivative using the finite difference approximation, and it's given by the y value a little bit to the right, take away the y value at the point, divided by, this is just the step size, x at index plus 1, take away x at index, that's just a delta x. And the only thing you need to do in this exercise is tell MATLAB what the index vector is. So looking back over here at my example, the index vector there was 1 to 10. It was a vector of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Previously, it was the vector of the numbers 1, 2, 3, 4, 5. So what you need to be doing here is inserting whatever the appropriate index vector is for this finite difference calculation. Now thinking back to, I think it was part 4 of these exercises, you might remember that we needed to plot x and its, the function and its derivative. And the derivative approximation only went up until the second last element of x. We sort of ran out of elements. So what we want to be doing here in the index vector, we'd start at 1 of course, but we want to go up to the size of x but minus 1. So what you need to be thinking about there is, if say x is equal to a vector of 0 by 0.1 to 10, let's not do that, let's just make it to 1 so we can see it all on one screen. 0.1's step size up to 1, so we've got 11 elements in our x vector. Okay, so I could say, what is the length of x? And it should tell me 11, I think. There we go, 11. It tells me how many elements are in that vector. So with my loop index vector, I want to go from 1 to, not the end of x, but the second last. So I want to go 1 to length of x minus 1. So 1 through to 10. So I think that's the kind of statement you could be using for your index vector up here in your for loop. Now remember, that is the only thing you need to substitute in here into your function. All the rest of it's done for you in this one, and that's all you've got to plug in. Something along the lines of that I think should be right. Anyway, that is it for a little intro to for loops, and in particular for this exercise in your MATLAB exercises. Do let us know if you have any questions, Facebook, email, or see your tutors or lecturers at classes. Thanks.